Welcome to Module 4, Lesson 1. Our I can statement is, I can use basic facts, patterns, and place value to multiply a multiple of 10, 100, or 1,000 by a one-digit number. Number 1. There are 8 bags of pencil top erasers for the school store. How many erasers are there if each bag has 70 erasers or 700? So the first thing it asks us to do is start with a simpler number. Represent how many erasers there are if each bag contains 7 erasers. Write a multiplication equation for the basic fact you know. So the first thing it's asking us to do is find a simpler number. Okay, 8 is already a one-digit number, so we're going to take 70 and 700 and find a simpler number there. So for the purpose of this problem, we're going to represent how many erasers there are if each bag contains 7 erasers. Write a multiplication equation for the basic fact that you know. Okay, so if we have 8 bags, and then there are 7 erasers in each bag. Go ahead and write your equation to show what this bar model represents. Press play when you have your equation written. So our equation would look like 8 bags of 7, 8 times 7 equals 56. Letter A asks us, how are 7, 70, and 700 related? We want to think back to what we've been doing with regrouping and renaming these numbers, right? Because they all have this digit 7 in the greatest most place value in that number. We could rename these all using 7, right? This would be equal to 7 tens. This equal to 7 hundreds. So how are they related? So we can rename each number using 7. Okay. We have 7 ones, 7 tens, and 7 hundreds. Letter B asks us, how can you use the renamed numbers and basic facts to find each product? Well, in the section before, we found that 8 times 7 is equal to 56. We're going to use this fact and our understanding of regrouping and renaming then to solve this equation here, 8 times 7d. We've already renamed 70 into 7 tens. So now we're looking at the equation 8 times 7 tens. It's equal to 56 tens. We need to regroup and rename 56 tens to 560. Now again, we're going to regroup 700 into 7 hundreds. 8 times 7 hundreds still is equal to 56 hundreds. Now, how do I regroup 56 hundreds? 5,600. Now, sometimes this can be a little tricky to do this regrouping and renaming. So we want you to think about our hundreds, our tens, and our ones. If I have 56 hundreds, the digits in the tens place and ones place will both be zeros. Okay, we know we would regroup that 500s to be 5,000s and 600s. So let's go ahead and answer. If there will be blank erasers if each bag has 70 erasers, well, we know there will be 560 because 8 times 70 is 560. And 5,000 600 erasers if each bag has 700 erasers, because 8 times 700 is 5,600. In a game at the school fair, each player tries to throw 3 balls into these baskets. Each basket scores different points. What will a player's total score be if all 3 balls land in the same basket? So it's going to start us off with if we use this basic fact 3 times 1. The player threw 3 balls, 1, 2, 3. They all ended in the 1 point. 3 times 1, how many points are they going to score? 3 points. But now let's say they made them into the 10. Back here, 1, 2, 3. 3 times 1, 10. 3 tens, or 30. Now they're getting more points and they scored it into the hundreds. So 3 times 100, 3 hundreds, or 300 points. And finally, this person made it all the way into the 1,000. 3 times 1,000 will equal 3,000. So then letter B is asking us what's the same about all of these equations. We want to think back to where it asked us how these numbers were related. Right? So what is the same? Do we see something that's related within this? In order to solve each of these equations, we used the basic fact of 3 times 1. So we can say they all use the fact that 3 times 1 is equal to 3. Letter C is now asking us to look at a pattern, and this problem's actually given us a little bit of a hint here. Do you notice how it has some blue zeros at the end of each of those factors? If we relate that number of zeros to the product, this factor of 10 has 1 0. This product has 1. This factor, 2 zeros. This product, 2 zeros. This factor has 3 zeros. This product has 3. Now, this isn't just the case of adding on zeros, right? We're thinking back to our place value chart. For this one, it would be tens and ones. 3 times 1 10 is equal to 3 tens. There's a digit 0 in the ones place. This number would be the same, right? Ones, tens, hundreds. 3 times 100 is 300s with the digit 0 in the tens and ones place. So when we look at this, we see this pattern that the number of zeros in the factors, right? In this case, we have zeros only in one of the 2 factors. But the number of zeros in the factors is the same as the number of zeros in the product. So if my factors have 1 0, then my product also has 1 0. Again, we're relating this to the idea of place value, and that when we have our place value, the digits 0 correspond to that factor. So now let's use our knowledge of these patterns and understanding of place value in order to solve check understanding. Go ahead and pause the video, solve the check understanding, and press play when you're ready to check your work. Right, so let's go ahead and check. Number 1, 4 times 1 is 4, 4 times 10 is 40, 4 times 100 is 400, 4 times 1,000 is 4,000.
So if one game gives 1,000 points for a win, how many points are earned after 4 wins? 4,000 points. Here we have another pattern over here. 5 times 8 is 40. 50 times 8 is 400. 500 times 8 is 4,000. 5,000 times 8 is 40,000. So if each box has 8 prizes, how many prizes are in 5,000 boxes? 40,000 prizes. Now I really want you to be aware of this number 40,000. In that last problem that we looked at on the Step It Out, it told us that we can use our zeros and our factors to help us solve. Right? So 5,000 times 8 is 40,000. Now if you notice, I have 3 zeros in my factor. I have 4 zeros in my product. So why is that? Well, my basic fact of 5 times 8 is equal to 40. So this 0 in 40, 5 times 8, is not a part of these factors. Right? So we have those 3 zeros in that 5,000. So it's really important when we're solving problems that we think through the place value and we think through patterns before trying to use a trick to find the correct answer, because we wouldn't want to get stuck by seeing the different number of zeros. So make sure you're really working on checking your work and thinking about the reasonableness of your answer instead of trying to just use a trick to solve.